Welcome to the Punch AGU office hours and briefing. This is our agenda, and you should have received, if you did not, let me know, you should have received a link to this page so you'll be able to look at everything at your leisure later. We're going to start with Craig, who's going to give the PI briefing. Then I'm going to tell you a little bit about how you can get involved in the Punch science. Then Marcus is going to talk about getting the data and what kind of tools we have for looking at the data. Then Raphael is going to introduce us to a new Google collab for doing flow tracking with Punch data. And then we're going to have about an hour of informal time to play with Raphael's Google collab. If you look around the room, those of you in the room, the people with Punch stickers or logos directly on their shirts are members of our Science Operations Center team. And so they can help you with all sorts of questions. Any of us can help you with questions, but they in particular. Oh, you need a sticker, Derek. Okay. So people online, welcome. If you have questions, please do put questions in the chat, and you can also raise your hand. And without further ado, let's go to the PI briefing.
All right, and it's just going to take a second to switch modes here. Got to drag that out. Back in, all right, and drag that out. And then put this one on. Oh, it's on, okay. Bam, and I have to share it. Let's see, boom, boom. Share window, share that window. All right, we're off to the races. Okay, so welcome. And let's see if this is gonna work. Yes. All right. I'm going to talk about status and our data. You've all seen this slide before. 4 Punch spacecraft work together. The thing you need to know is everything is working. The 4 spacecraft are nominal and data are flowing. We are publishing preliminary data right now. Right? We're up to version I. So the data are being produced at all levels. It's a partial data set. Not all of our level 3 products are available yet. And they're versioned, and they're version 0 with a lowercase letter afterward. We're up to I, so this is the 9th time we've done this. And the SOC team are very intrepid and have worked through a great deal to get us here. But there's more to go. Here's the science. I'm not going to belabor this. You've all seen this a million times. This is what we're here to do. Is answer these 6 questions, and there's a lot more stuff that's come up along the way. Available right now, you can get full field of view, trefoil mosaics and averages at level 2 and level 3. Those mosaic products do not have NIFI included. NIFI is being processed for the Quick Punch product, but it's not photometrically compatible with Wi-Fi. So I've asked the team to focus on getting Wi-Fi hammered out, and then we'll switch to merging NIFI. You can also get NIFI stuff separately, and you can get 32-minute averages. So there are 2 products, CAM and PAM, which you'll hear about later, which are full circular disk averages that have lower noise. And hopefully we'll be working with some CAM data tonight, right? Okay, this is the various limits. 80 solar radii is our nominal continuous coverage limit, and we're actually meeting that pretty well. So milestones this year, we have a lot. We launched, that was great. Raw, go us. April 14th was first light. We had great first light images. PLAR was May 21st. That's when we had finished commissioning well enough to know that everything was working as intended. June 9th, we had a HALO CME press conference at AAS covering a HALO CME that had happened just 9 days earlier. So go SOC team getting that all out. Well done, Marcus and Sam and Chris and everyone, Ritesh, who pulled hard. The constellation finally drifted into meeting the observing requirements in late July. That's great. Maneuvers were ongoing at that time. On August 8th, we arrested the constellation drift, and we have not maneuvered since then. Really nice. August 20th, we got up to version F of the data. That was the first data where it really made sense as opposed to being dominated entirely by stray light variable things. and calibration effects. August 21st, not coincidentally, the day after the F data were released, we had the play in the sandbox. Many of you were at that. September 13th, we saw Comet Swan and the punch data 2 days after it was announced to the world. I guess 1 day after it was announced to the world. It was discovered on the 11th, announced on the 12th, and we saw it in our data on the 13th. We released version G data about a week later on the 19th of September. And then a couple of days after that, 3i Atlas entered our field of view. On October 15th or thereabouts, we downlinked our 500,000th image from space. Just to give you a sense of what we are doing here, we are already well on our way to 1 million images, having just started the sequence going in early June or late May. Version 0H data were released in October, at the end of October. Not coincidentally, a day or two later, we had the second bi-monthly meeting with more tutorials and planned our first coordinated study, which you'll hear about from Sarah. Eclipse season began on December 8th. Remember, this is anticipated. When the sun goes too far to the south, we start to go through Earth's shadow every time we cross the North Pole. And so we're doing that now. The WIFIs are continuing to take data. However, they are affected by terrestrial stray light during that interval. So the data are a little bit degraded during eclipse season. Yes?
In the eclipse season, it might be a good time to see if you're seeing a mirror.
Yes. And in fact, we have not gone looking for it in detail, but we have done a few cursory searches.
Is that have less other light?
Right. Oh, well, the WIFIs are pretty good at getting rid of sunlight. They're pretty good. 16 orders of magnitude is a lot of orders of magnitude. So we should have seen aurora and have not, and that's a conundrum. Yeah. But we need to look at that a little more thoroughly in the weeks to come. Version I data was released on the 11th of December. We had our first background subtracted polarized movies published on the 13th. And the 18th is today here at EGU. So that's sort of some milestones that have happened so far. This is a lot. I haven't shown everything of import, just the very highest lights, but there's a lot going on. You've probably seen this a few times this week. We're very proud of this. This is the noontime sky as seen by Punch today. It will only get better. That flickering is going to go away. And I want to call out to everyone, this flickering is visible not because the photometric calibration is awful. We are photometrically calibrated to better than 1%, but we're subtracting 99% of the light in those images. And so that brings the artifacts back up to where they're visible. And so I owe apologies to the SOC team for making your job so much harder by looking at a target that we have to background subtract. Let's see, Sarah, did you want me to narrate this or should we just keep moving? I'm thinking we should keep moving.
We should probably keep moving, but I think during the breakout time, if you want him to give you kind of a guided tour of the heavens, it's lovely to listen to. So that's one of your options for the time is to go and have Craig narrate that to you.
And I will do that at the end if there's time. Okay, and this is that view with constellations added. Thank you, Chris. Thank you, Sam, for making the movie. Or Chris made this movie, didn't you? You made this movie. Right. Oh, okay. Both of you. I got it backwards. And just take a moment to marvel at how small these constellations are, right? This is a 90-degree field of view, and nothing really drives it home like seeing this large view laid out. Ritesh has been looking at the polarimetry, and for the first time, we now have polarimetric movies that make sense. And so I don't know why PowerPoint always barfs on this. This is a little piece of the large movie that you just saw. It is polarimetric using the RGB scheme that we've been using. The saturation is boosted to make it more obvious, but I want you to see, A, that it makes sense. The rainbow occurs twice around the perimeter of the sun, so we're seeing the coronas polarized the right direction. And that CME that's coming out is polarized. So we can actually resolve polarization. We're not quite to where we can do it quantitatively yet, just qualitatively, but we'll get there. Also, Raphael, thank you, just recently demonstrated that yes, the feature tracking method or the correlation tracking method for solar wind speed measurement works. And so we have, this is our very first wind speed measurement using punch. And you can already see that there are two different types of solar wind around the perimeter of the sun. That is really cool. You're seeing fast and slow wind accelerating out at 50 and 80 solar radii. And they both sort of fit the profile that we measured with stereo. So very cool. Refinement will come. You'll see a lot more of these, and they'll be time dependent, and there'll be many altitudes, but this is the first one, and so it's worth seeing. Yes, ma'am.
Did y'all compare this to the current sheet tilt angle yet?
No, we haven't done that yet, but we will. All,
Right now it's the. No, I mean, just so that you know where the slope should be, that's all.
It's not gonna be this. Yeah, the Sam's, so the great thing about Sam's SWEB tool is it's available all the time.
so for those online, Nikki is saying the great thing about Sam's SWEB tool is it's available online all the time for everyone. It's in CCMC. All right, cool. Let's keep moving. All right, so bonus science, you've probably seen, we routinely track comets. The top is a version of punch data from, this is version F data that I just glommed together manually. You can see Swan being tracked there. This is Mars that we're going by, Spica down below. And then if you look down in this path that I've marked here, you can see a little faint thing moving with the cursor. It'll come around again right here. That is Comet Atlas.
It looks like a fruit fly to me.
And we've actually been doing a lot of great science with it. The first punch science paper may actually be on Atlas. We can track the tail. We've seen eruptions. It's really cool. And down here, this is more recent data, version 0I. You can see Comet Lemon being tracked. So great stuff. All right. Data are available now. Go to the VSO or STAC. Apparently, the latest are not being properly indexed by VSO, but they do seem to be appearing in STAC.
Yeah, can I make a comment?
Yes, sir.
So, because in earlier, there is only one hand the announcement that data are released, and so yes, there is it can be a lag before all the data are indexed and in the STAC, and so if people don't see the data available, that it's just a matter of time that for them to get indexed, and people trying to get them directly from the STAC without using VSO, they might get them faster.
Yeah. So STAC has them organized in a hierarchical file system, and there's some pretty simple algorithmic tools using wget to get what you want. But once they're indexed, which I don't know why it takes so much time.
So I asked why it was so slow.
Yeah.
And they said that it's going to be faster, hopefully in the new year. They're like upgrading some of their scripts and moving to a different building with different switches and all that stuff. So hopefully it gets better.
So at one point, for those online, Marcus got a phone call from the VSO sort of saying, could you please not re-index your data so often? Okay, so upcoming events. Abstracts for Punch 7 are due early January. I know Sarah wants them on the 9th. We'll see how well that sticks. But Punch 7 is in May. So speculative abstracts are okay. You can submit an abstract that says, this is the work I intend to do. So please put a marker down by the 9th of January if you can. Next bi-monthly telecon is January 29th. Punch 7 is May 12 through 14 in Boulder, Colorado, and I hope to see you all there. And version J of the data will be out in January, J for January. The team are taking a much needed rest over the holiday, and things will slow down a little bit, but we'll ramp back up and try and get the next iteration out in early January. So many thanks for making operations work. I want to call out a few folks. Our fearless SOC team, who are named here, have been working basically for 6 months, long hours, just to get what seems like a simple problem, but is in fact very complicated done. We have, I think, what is it, 140 data products that we're managing?
It's a large number. It's more than 100.
Yeah. We have our intrepid operations team that's led by Jillian Redfern, but all of the folks named there are great. Will Wells, the PSE, who's been keeping everything healthy. Business, Florine Leighton, we wouldn't get paid without her, so thank you very much. And the development team, Ronnie Killo, who's in the room here, who's basically channeled his inner Shackleton to get us to launch. And of course, our NASA representation, Devin Poland, Nikki Vile, David Cheney, Lika, many others at headquarters. We have a lot of allies who help get us over the line. And Barbara Thompson, who's on the team. And the science team, you guys. And we're about to hand the baton off because the data are ready. They're not perfect, they're not final, but they're ready to do science with, and we can start getting things done right now. So with that, Sarah, did you want me to talk about nomenclature now or later?
Do that.
Let's do it later. All right, I'll hand over to you. Yes, absolutely. All right, I'm muting me and letting you.
No, you keep this up because
Oh.
I'm in.
Oh, okay. Oh, right, you can't. Okay. So.
All right, so this will be fairly quick because I'm basically going to give you a teaser so that those of you in the room can come up to me during the office hour, and those of you online can just send a text. This is basically our plea to you, our encouragement to get involved in punch science. There's lots to be done. This is our website. If you go to our website, we have information there, including links to the data access, which you're about to hear about from. Yeah, can you make that bigger?
Oh, bottom right. There it is. Okay. This one?
No, on the other image.
That?
Oh, sorry, folks online. I think some.
Above the smiley face.
Smiley face. Oh, there.
In that corner of the, go up. Okay.
Oh, enter full
Yeah.
screen. There it is. All right.
Or not.
Oh, so there was a double arrow, a double-headed arrow.
There it is. All right.
Okay, folks online, we're back in business. So you can find out about punch science, and you can find out about our topical work focus groups. We have what we call science working groups, which are basically doing the NASA compliance for what we need to do as a mission. But the topical focus groups are groups where we get the community involved. And the one that we're ramping up now is called the Snipe Hunters, the super nifty punch event hunters. And I don't know if anybody recognizes this. I don't know if everybody recognized the reference to snipe hunts. They're a bit of a, well, let's see, how shall you call it? A prank. A snipe hunt is something you do when you pretend that you're going to go hunt the magical bird, the snipe, but there is no such bird. But in the movie Up, of course, the lovely end to that story was there was in fact such a bird. And our point is there are in fact super nifty punch events. And so this is just our way of gathering the people to look for the best events. How are we going to do that? This form here is one which oops, that's right, I did screen grab. It has the following information. We're going to send this out to Solar News. We're going to put it on our website, but you guys get a sneak peek. This is a Google form which solicits community help identifying observations of interest. They might be particularly nifty punch events, CMEs, CIRs, jets, comets that you see when you're looking through HelioViewer. It might be time periods when other missions or projects have interesting data and punch provides the context. So the output is then going to go into a moderated spreadsheet, which we also will share with the community. And this will be a way of kind of gathering science collaboration. And you can see the sort of information I have here, but I seek your feedback of things we might add, what type of event it is. It might be a CME, CIR, jet, comet, whatever. Do you know, are you doing this because you know of good punch data? If so, tell us where and when, and we'll get that information into the spreadsheet. Do you know of other mission or project observations? In which case, tell us, and we'll get that into our spreadsheet. And is this something that you personally are going to work on? This will help us get people in touch with other people to try to bring together, because as you'll see, well, you'll see in a moment, the kind of thing we have in mind. Now, how are we going to communicate about this? We have this spreadsheet, but we can also communicate through the news nuggets. We have these going out on our website as much as once or twice a week. And our sandboxes, our bi-monthly meetings, are another way that we can kind of bring people together to work on certain areas, as well as other gatherings like this one. But we're also looking for any suggestions.
Excuse me.
Yeah.
If there's anyone here who's not getting nuggets, you can raise your hand if you're not embarrassed about it, but Sarah can show you how to get nuggets.
Yes. That if you're on the Punch Science mailing list, which I think you are, you should be getting the Punch Science nuggets. But if not, tell me and we'll figure out why not. Yeah. Okay. Here's our example. So we did this as one of our bi-monthly sandbox. We had 85 attendees. This was in October. It was a HALO CME originating on August 30th, 2025. And we had people, we had a 2-hour event, virtual. We had remote sensing observations from SDO, from Owens Valley, from Lasco, Stereo, Parker, Whisper, as well as in situ from Parker, Stereo, L1 Discover, GFC Potsdam. We had modeling, Gong, Enlil, Alivo, and 3D Core, ICME shock analysis, tomographic prediction. If you go to our webpage, you can find the Google Deck with all these presentations. So this is something that we're presently working on. And the next step is, from the point of view of Punch, is to say, okay, we got all this wonderful information from the community. Now that we're going to our level J or level I data, how can we use Punch to fill that middle piece between the remote sensing near the sun and the in situ far from the sun? Can we look at evolution of substructure? Can we look at the interaction between CMEs, because there were more than one CMEs involved in this? Can we look at how things are different from models, because we can see the CME evolving in a region which until now we really haven't been able to. And then how do we coordinate all this? And this is my step, will be to have another Telegon con asking anybody. I'll send an email to Punch Science. You should all be on that mailing list if you're not already, and invite you to get together and think about, shall we put together a paper, etc. So that'll be the next step. But this is an example of what the snipe hunters would do, is to find cases like this and coordinate the collaboration. So if you're interested in this, we will probably set up a sub-mailing list for this. And until then, we'll be sending stuff to Punch Science until we get organized. And then the last thing I wanted to say is just to double down on what Craig said and say, please, come to our meeting in May, May 12th to 14th, and turn in your abstract. So with that, I think we're switching.
Let's let those people in.
Can you bring Marcus's one? Does anybody have any questions?
There should be a way to prop that open if we need it.
Yeah, I see that.
Any questions? And of course, we have time at the end for all sorts of questions. It was too noisy, that's why.
Do we want to, it is kind of loud.
Yeah, you can go up.
Maybe prop it mostly closed. Yeah. All right. Let's see. So you want to do, are you set up for?
If I stand here and talk loud, we'll go through the.
Yes. Yes, it will. But it's going to take just a second. All right. So we need to set up slideshow. Do it in a window. Okay. Go. All right. And I will share now to the folks online. And you are good to go.
Okay. Go to the next slide, please. Hopefully.
Boom.
Perfect. So we have to put this video in every single talk because it's just so magnificent. While it plays, I want to take a moment to introduce the SOC more slowly.
Yes.
So Derek Lamb, can you raise your hand? Sam Van Kooten, Ritesh Patel, Chris Lauder. Oh, we're all next to each other. But they will distribute later. So when we have the second hour, if you have questions or you see them tomorrow at the conference or something, or you just want to email somebody, everybody's happy to help out. So I'm going to quickly talk about how to interact with us if you're not in the same room, talk about some data availability things, give you some updates of things the SOC has learned this week, and then things that are going to come because of that. So just a reminder that Punch, in my mind, and I think in the PI's mind definitely too, is a very open mission. Our data and our software are all public, so you can go look at them as soon as we make them. There's no kind of embargo period. And if you have questions, you can go to our GitHub, which we're going to go to in just a second, or you can always email us at punch_soc@sweary.org. So this, if you go to the GitHub, I keep saying this, but please go to the GitHub, has a lot of resources, and we're going to keep adding more resources. So if you were to go there and then you go to Punch Bowl, or you just see at the top of that first page, there was a discussions tab by itself. You can open a discussion to ask a question. Gilly did that recently to talk about an idea he had. If you have an issue or you find a problem in our code, open an issue. If you're not sure, first, you could always go check the documentation, but if you can't find something you want to understand, discussion or issue. I think you have to click on this movie. I should have made it auto start. Yes. So Sam made this beautiful movie for his talk, so I had to throw it in. But I just wanted to point out that the Punch pipeline is very complex, and it just keeps getting more complex all the time. And so this is what's happening in our pipeline so that we can produce these level 3 images that you'll use today. So now we're assembling mosaics, we're moving the F corona, and eventually, with the final version, or the version 1 of the data, the star field will also disappear completely, but it's just suppressed a bit here. Yep. Again. Okay, so let's talk about the data. If you were here for another talk, you may be a little bored by this because I'm repeating this, but I think it's good to remember that the file name has a lot of information crammed into it. It has a product ID, and then it has a date of observation and a version. So we'll talk about all these. I've highlighted a little bit of the level 3 products on the right. So you'll see that each level 3 product has a code. And so that's what's happening here. Level 3 PIM is the polarized intermediate mosaic. And you can go read about it in the description over there. Heather had the great idea that we should highlight which of these products are most helpful. So right now, I'm going to tell you that the PIM are very helpful. So you should focus on them. That's our polarized intermediate mosaic. But eventually, you'll switch over to the PTM products and the PAM products as those get improved. But we will highlight this. That's one of those takeaways of things to improve. So we have lots of product levels. I would suggest focusing on level 3 unless you really want to dive into the details of the data. We're going to focus soon on this level, this quick look product, so I'll talk about that in just a moment. But each product level increases the processing on the data. The data versioning, I think Craig already mentioned it, but I just want to point it out one more time. It's a number and a letter, and each increment of the number or letter, higher one means a later version. Version 1, we're targeting March, February kind of timeline, which will be a nice stable version, but you can go ahead and start using the data now. Yep. Just the summary that you can get the images. I think you may have all already tried to get the images from the STAC and the VSO. We have a little example on our website about how to query the VSO using SunPy, or you can go directly to this VSO. We're just going to keep trying to make it more accessible. We talked about this some in the past. How can you share your own tools and software? From the SOC's perspective, we really want you to share things with us so that way we can share them with the broader community. So you can, if your code is Python, we'd like to put it in our documentation and just let it run. Every time we make a modification to the code, we can make sure it always works. So then that's kind of the SOC owns it a little bit, but I mean, it's your code. but the SOC will maintain it for you to make sure that the documentation works. If instead you want to just link to something, we've added a few examples to a list on the Punch Mission repository of the SOC's, the Punch Mission organization. So I was thinking, and I'm not sure this is an exhaustive list. I think there are a lot more things that have come out of this week for the SOC, but I just wanted to highlight a few things. Sarah just mentioned collating a list of scientists curated events. So that's a thing that's not just the SOC, but we'd like to help out with to make sure that the science can be done. We've heard that requests for quick look movies, and we'll be moving to make those very soon. We actually have code that's already making quick look movies on our servers, and we're just not giving them to the community, which is bonkers. So we're going to do that. We've added some new tools to our list already this week. The data was highlighted in a press release. It's been talked about in conference talks, and members of the SOC even presented. So let's move on.
Wait,
Yep. Yes.
For your first point, that's awesome. The SOC wants to collate and link to scientists, blah, 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 scientists carry the list of events. How do you envision that you guys are going to actually do that?
Well, I think we're doing this through Sarah's form. We're not really doing it as much as we're going to link to it. So that way we're not going to duplicate the effort. But
But you're not going to make a new folder that pulls out special images. You're just going to say,
right.
the CME happened on this and such days.
So you can go grab it from the normal method.
The data will still exist in all the.
Yes. Yes. And so I was thinking we're going to compile this spreadsheet, and we would like to make sure it's linked or integrated into the Punch documentation so that way it's easily accessible.
And we could probably, I mean, we can talk about how to set up a path to the, I mean, it's just a question of like dates and times, and the dates and times can go into the FIDO script to pull the data. So if somebody wants to do it, it should be they should be able to do it without somebody having to do it by hand. But the spreadsheet feeds the dates and time into a FIDO that and then
Oh,
we
and then
generate
like a little
a
script.
little script. We could write a little script to make a movie that goes with the spreadsheet. That should not be a problem.
Separate code from data.
So things that are coming, Craig has already mentioned that the January version J, we planned that all along. We'll have some nice new features like the cosmic ray removal. We're going to focus on improved distortion models. We already have some in hand. We're going to work on the single instrument flat fielding. We made lots of improvement with intercalibration with this recent version, but we've got some work still to do with the inside of a single instrument. And that's kind of the same lines with the better stray light removal. They all go hand in hand, it turns out. Version K will come after version J. And we're hoping to improve the Nifty stray light, and the star field subtraction should be coming soon as well. I don't know if it'll be K or not, but it'll be very soon. Just to repeat myself again, the quick look movies, we're going to release these. You're going to be able to access them through HelioViewer, or you can download a movie directly from SDAC as our plan. I think I put this slide in here twice, so let's move on. And this slide was intentionally twice because I just want to repeat that we're always here to help. So the SOC is here tonight and also will be available through the interwebs at your disposal. And I think that's the last slide, except for the beautiful frame of this movie again. So I think we can move on to Raphael now. So don't go away. Unless there are questions, I should have stopped there.
Yeah, why didn't you say if there's any questions?
Yeah.
And we can, of course, take many more questions.
I would actually like to call for Vince to come up.
Did you have a question, Dylan?
I was just, one is Starfield, is it just the right?
Yeah, so I think part of the problem right now is because of all of these earlier steps that are not dialed in completely, you'll find that the star brightness is not constant. It's not consistent. And so you might be able to remove it mostly, but we want to do it all the way. And so we have this code in hand to remove the star field. And so we've been kind of focusing on the earlier steps to get them correctly dialed in. So that way the later steps will work as well. Any other questions? Jillian.
I'll just announce that I'm over Sweden right now.
Yeah, you're going to pass right now?
Yeah, and we'll continue to be for another like 15 minutes.
Is it talking to Sweden at this moment?
Yes.
Excellent.
It's
Can you repeat?
So Jillian announced that even as we speak right now, NIFI is,
no, it's
Oh.
53.
I'm sorry, Wi-Fi 3. Wi-Fi 3 is talking to Sweden and doing just fine during the eclipse.
Are there any
All right.
other questions? It's not your last chance, but it will be the last chance for right now.
All right,
we can
let's
get-
go to Raphael.
So Raphael is now going to lead us through. Raphael's gonna, so if you go back to the agenda, there is, and you follow the link, you'll see there are two files. One of them, Raphael, are you gonna come up front or are you gonna,
What's that?
will you come up here to give?
I'll come up here, like here, there.
Yeah.
Yeah.
So there are two, on the agenda, there are two things. There's the setting up the interface. That's to help you to actually do the same thing that Raphael's doing. You don't have to do it in real time right now because we have an hour after this where you can work through it. We can help you troubleshoot. But he's gonna
Just-
demo
can you
this
share on that?
collab that you also can get access
Where
to.
can I sit?
Oh, right here will work.
But you want to be near the mic.
Near the,
Or you can turn on your own mic.
yeah, where's the mic?
It's in my computer.
Oh, it's your computer, the mic. Okay. Is that part? Okay.
While he's sending back in, just see your product. So we have Raphael's code. So we're gonna do this for you, but right now, while we're working on this, you can make your own flow maps until we have produced them automatically.
Okay. Can people hear me okay, or am I far from?
So people online, say something if you can hear Raphael.
Can you guys hear me okay or not?
Yes.
Yeah.
People behind you.
Yeah, they hear you fine, but those people won't hear you.
Yeah. Why don't you swap?
So you gotta face the audience.
You want me? Okay. All right.
We're having a good time out here.
Yes. We're all tired. We don't want to stand up.
It's day 4 of AGU.
This begins the part
like a
where the
teacher
song
one.
can help out if you just like have a question.
All right, so I'm gonna share my screen. That sandbox thing. All right. Okay. This. Yes. Okay. So hi everyone, I'm Raphaël Atier. So I've written this notebook to show you an example of for a particular case study, from November 5th to 7th, where we had lots of CMEs, very active sun. We chose that date because the data are going to, yes, Craig?
Let's point out one more time, people can get to this from the agenda, right? There's a link to the sandbox from
Yeah,
that?
and I just put in a direct link so you can go to, if you go to the link that's in this, you can basically get to something which will show you how to access his folder, his file as well.
Let me bring up that page.
Yeah, why don't you bring that?
Yeah,
Just
I'm
to
gonna-
Right there. So
If you just click on that.
in the chat, if you're in the Google Meet.
I'm going to share my desktop. Yeah, entire screen.
I hope you guys online are having as much fun as we are.
So, yeah, you should have received an email from Sarah. It will give you the instructions on how to get to the collab and how to set it up. So if you haven't done that yet, please do that. It takes a few minutes. If you're-
But you could do it during the breakout.
Yeah.
So why don't you just walk them through it? and-
Yeah.
Okay.
Sorry to interrupt you.
Go back. So if you are doing this from the collab, just be mindful that if you're on the free tier, this is going to pull a lot of resources from your free tier collab virtual machine. If there's a crash, it's possible. Don't panic. That's because the processing takes a lot of memory, and depending on how much resources Google has allocated for you, you may run out of the resources. We're over the edge there. But yeah, hopefully you won't have that problem. I didn't have that problem. I'm on the free tier. But you know, Google's told me that no, you are the limit of the resources, so it can happen. All right. So we're gonna go through that, and what you need to do first is run these pip install things. They just install necessary packages, and there are only two. A very important package that we need is OpenCV, because it's a highly optimized library of computer vision, and it takes care of the polar remapping. We'll go over that in a minute. The second package that you need is Punchbowl. We need it because, as you can see a bit later, we need to import the color map for Punch so that you can see the data and the figures in a nice color map that the Punch has implemented. All right, so this command to install the necessary packages takes a few seconds to run. And at the end of that, you may be prompted to restart the session. That is normal. And the reason for that is because Punchbowl is importing its own version of Matplotlib, which is at the lower version of the default version embedded in Colab. So as soon as, when you import this Punchbowl, you always have this sort of conflict, but it's totally okay. We'll ask you to restart the session to take into account the lower version that is Punchbowl, and you'll be all set. So depending again on your internet connection, it might take some time to download everything. Okay, so what is doing that? Let's see. Are everybody who is done with that step already? Yeah. Oh, you did it already? Awesome. So can you raise your hand where you clearly so that I see there are only 3 people who did their homework? No?
Well,
Okay.
we didn't, let's be fair, we gave them the data, we didn't give them the collab until like right now.
Yeah.
So.
All right, so just hit all right, so you see eventually you run into this restart session thing. So you can just do that. Once you've done restart session, we ask you to run the same cell again, just to make sure that it went all right, and it's not gonna be as long as before, because you've already downloaded everything. It's just it's gonna see that you've downloaded everything. It's gonna tell you that the requirements are already satisfied, but we just want to make sure you have the little green check mark on the left of that play button, just to make sure that everything is okay. And here you have it. 20 seconds. If you have a green check mark, you can go to the next step. So the next step is also a very high-level setup thing. It will mount your Google Drive so that you can access the data that you've downloaded in your Google Drive. It's necessary to do that if you want to have what we call a persistent data, because when you use Colab, you're actually in a temporary space, and so if you upload the data on the left-hand side here, it's going to be accessible, but only for a very limited time. And the amount of time that you have is highly dependent on your personal account. So you can see here, if you click on this little RAM disk thing here at the top right, you under resources, it actually tells you how much time you have before this whole session that they call the runtime runs out. And so after that, you lose everything you've done before, all the data you've uploaded in that space on the left. Yes, Heather?
I did download the data to my copied it onto my Google Drive, but still don't know if I put it in the right place.
It's okay. So you uploaded it in your Google Drive?
Yeah.
That's fine.
But I don't know if it's in the right spot. Maybe we tackle that.
Yeah, we can tackle that in a couple of cells. Wherever you've put it. If it's not where you're supposed to put it, what matters is that you know where you've put it, and you can make a very small edit of the path in the code. I'll show you where.
I put in the notes for in the slide that nominally so that you could do it without editing his collab. You would create a folder at the top level called data. And inside that folder, a folder called punch. And inside that, you put your data. And then his collab should work out of the box. But again, we can troubleshoot that after this.
All right, so my thing worked. Okay, so I think in my case, because I've already mounted my Google Drive, then nothing much to do there. But in your case, you've never done it. What it's going to do is going to prompt you to access collab. The collab is going to ask you to give it access to your personal Google Drive or professional Google Drive. You have one. And depending on your case, you may be asked for some 2FA stuff, and you can be a pain. And so if you're stuck there, let me know. And if it's too long, you can just follow passively, and we'll tackle that later. Actually, I got a very different way of mounting it from the hotel than I did when I was at the HAU thing. No idea why. But yeah, histories of Google. Okay, so then the next step is who managed to mount their drive? Okay, so you will see once you've mounted your drive, if it worked, if you have the green check mark on the left hand side, which you access it. You see this little icon there. You click on there and you have your file system that shows. And so if you've mounted things, you should see now a drive folder for those of you who mounted their Google Drive. So if you look at that, you will see under it there is my drive, and this is actually your other Google Drive folder that you see when you go to your personal Google account as you're used to. So in my case, it's very different. Oh, you see my life there. Okay. So this is basically where you can header. You can check where you've put your data. And so what's a very neat thing, and we might need that later for those of you who didn't upload the data right folder that is normally by default where you have to put it. So a little trick, I'll show you where is the punch thing. So from there. So once you've located where you've uploaded your files, if you click on there, you can do a copy path, right? And that will give you the absolute path for that.
I see what you're saying.
So all right, so we can go at that again later. What time is it? How much time?
About 5 minutes. So we can go through the details. Why don't we just go quickly through it and not wait for everybody to catch up? So we've got an hour to work through that.
Okay, perfect. All right. All right. So then you have the import things. Let's do that. It's very quick. It should be. Then function definitions. We can run through that as well. And it's a bit long. Put that again. Here you have some. Then some constants. Nothing particularly illuminating here. And so here I'll just pause for a minute. So this is where we really need to make sure that you've got everything working. So this is the path to the files that you've uploaded, the feed files. So you need to have that working if you want to continue. So you see, in my case, I've made it so that it goes to the relative path, which is a drive, which you see on the left hand side here. And after that, this is wherever you've put your file. So in my case, if you followed Sarah's instructions, you've put that into the archive, if you download it, and then zip will live under data punch under your drive, under the root folder of your drive. And header, if you put that anywhere else, this is where you edit the path. Perfect. Perfect. And again, if you want to make sure, use the trick that I showed earlier, where you click on the little three little dots, right? Here, 3 little dots, copy path. You have to make sure that you have the same address, or if it's a different one, you need to override. Okay, and then we will go through that. And I have made an error check here. This assert thing will just simply issue an error if you have a wrong path. If you cannot find your file for some reason, it will have an error. If things are set up correctly, you will not have an error. So if you have an error, let me know, and we'll work through it. Okay, next step is simply loading just a sample, just the first image of the series. It's also making sure then that you've got your data set up properly. And then we're gonna plot a preview of those data. So this cell there, where I say get and plot a sample test file, is simply getting some intensity scaling values for the plotting function. Nothing very scientific there. The next cell is simply defining the function that's going to plot things. Nothing particularly illuminating there. And then you run the plotting function that's going to plot a preview of the first fix file, of the data in the first fix file. So for the minute that I have left, I am simply here showing you the how we work with the flow tracking and the correlation-based tracking. On the left, you have the data in the natural state, where you have the sun. I've overlaid two circular lines that are showing you where we're going to measure the flows. And on the right, this is what I call the polar remapped version of those data, because it's very much more convenient and more computationally efficient to run the correlation-based tracking on the solar wind on this polar remap thing. What's that? And so we're going to operate the correlation tracking operates with this polar transform. And you have on the bottom axis, the horizontal axis, it's the latitude axis. The vertical axis, it's a radial axis, which goes from the center of the sun, which is right at the bottom, up to the edge of the field of view. The bottom is simply the crop that is taken between the yellow continuous bottom line and the upper dotted line. That's all. And this is really where we're going to measure the flow. The data that you see there are the level 3 CAM data. This particular data series was chosen first because we had all those CMEs, and the reason we use the CAM data, it's simply because they were the most advanced data products that were available without missing gaps. However, bear in mind the cadence of that of the image, the time interval between each image is 32 minutes. For our to meet our minimum requirement, I am not actually supposed to use that. I have to use data at a faster cadence, which are the PIM data. So these were at the time that we developed this, they were not yet fully available. So this is why we use the CAM data. However, we managed to have something working the CAM data. So that means that it is very promising because the PIM data will be even better. And so that gives us some guarantee that we'll get something really, really cool. Is that right?
Well, why didn't you tell them to show the?
Okay. So then we continue. We're setting up here some variables that we can work with physical dimensions. And finally, if you can go all through there, it'd be nice to start running that because that is actually the correlation tracking. It takes a lot of time. In my case earlier, it took half an hour to run through that. So it would be great if you can already click run on that and so that it runs while we're having this a little break, right? But that part will take about 30 minutes to run.
Not in the sock later.
Done in the sun. This is a very collab thing.
Scroll down that because you already read it, so did it. So show them what they're going to get because mine.
Yeah.
I know you've done it. Yeah.
All right. So this is what you showed. What Craig showed earlier. You're supposed to get that later once you run everything. And so the longest part is what I run just now. And in the end, this is where you're going to get. So I'm going to explain what that is. All right. So this is a flow map inspired from what they do in weather measurements to show you the winds. So I call that a rose chart. Very cool. And what this is simply, the radial axis is a velocity speed axis. And you can see that it is here, it is in kilometers per second. So the yellow line, continuous line, it's the velocity around the sun and an altitude at a given altitude. Here, 50 solar radii. The orange one, dashed line, is the velocity at 80 solar radii. So you can see that there is a faster solar wind speed at 80 solar radii on average, compared to what we have at 50 solar radii. But this is done synchronously, right? It's with the same data set over the same time period. We make these two measurements. On the one hand, at the same time, we have a measurement at 50 solar radii, and at the same time, we make a measurement at 80 solar radii. The choice of 50 solar radii and 80 is very arbitrary. We can actually have higher granularity. You can measure it at 50, 60, etc. That is completely arbitrary. However, I've chosen the two extreme of the field of view, where you have the bottom, I showed earlier the bottom, and I'll show it back here. Bottom line, upper line. This is because these are the places between which we won't have any gap in the PIM data. Outside of this band, we will have gaps, because of the traceable pattern. Any question?
Ask, well, first of all, so to be clear, the data that you've provided is a sample one, just so we have something good to look at today. But the Google Collabs like this, we're going to be making available through the GitHub so people can do it. And we'll probably, you can have an update where somebody might be able to put it where you might have like a time stamp and they could create it from the most up-to-date punch data. Is that correct?
Absolutely.
Yeah.
Great.
Go ahead.
Yes, that was one question. And the other question, can you zoom in on that?
On
You
what?
might
On that?
zoom in on so the people in the room can see it. Yeah, exactly. Okay. The other question I had was the Python, this collab notebook could be edited for them to do their own custom location of where the flows are, correct?
Yes.
Okay.
Yeah, and I will show how to do that, when we're reaching.
So I have a shill question, a planted question. Do you have to use Google Colab, or can you put this in a regular Python or Jupyter notebook?
Oh, absolutely. I never use Colab myself, so that's just for the sake of presentation. If you use, of course, that locally in your computer with Jupyter Notebook, it will run much faster. And yeah, absolutely. And the notebook, the Python notebook is set up so that you can do that locally as well. 2 minutes to run on your personal computer. Yes. No, I'm not a big fan of Colab, and this is only for educational purposes, right? And so yeah, in Colab it will work, but we're very slow, and it just show you the lower limit of how slow we can move.
So the benefit is if you don't have Python set up, you don't need Python set up. Anybody can do this if they have Python. Other questions before we break?
I want to throw up a slide on nomenclature.
Of course. So while you do that,
One quick question.
Yeah.
So after the domain that you select, you said there's gaps, right?
Yeah.
The correlation tracking algorithm can handle.
It will work where you have no gaps, right? And so it will not crash, but then you have to mask out wherever you had the gap, right? So because this is advantage of correlation. We chose correlation-based tracking because it's a robust algorithm that will not crash. But on the other hand, it is up to you to mask it out where the things are not physical. I'm sure we will have other sections like this where I will explain again. I will explain further how to mask that out.
All right, before we break, I do want to take a quick aside, and I'm not going to walk everyone through the details of it, but we do have a lot of quantities we deal with. And it's important that we have standard coordinate systems, standard names of angles and things, and standard names for our measured quantities. So I and Sarah and Kurt and Anna have all put these in our papers in the special collection. But the punch overview paper has an appendix, as do those, which features the figures I'm about to throw up. So please refer to them. We have a standard, well, I mean, you don't have to cite the paper.
You're gonna put the figures on the screen.
Yeah. Oh, throw up?
Never mind, just keep going. Craig.
Moving right along, throwing them on the screen. So we have a bunch of angles here. This is a diagram you've seen varieties of a lot. If you are familiar with the early Howard and DeForest papers, we mirror reverse them from that. So we have an observer, which represents punch. We have the sun. We have various angles, the scattering angle chi, the length to the feature is L. I promised you I wouldn't walk you through every single one, but know that there are standard surfaces, standard names for them, and you should refer to those. When we use Cartesian coordinates in the solar system, we have adopted RTN coordinates, which is a little weird if you're coming from the imaging community, but it's standard for people who do in situ work, which is where we are working. We're working in an area where we need to merge with the in situ community. And so Z goes up, it's like image Y. Y goes to the right, it's like image X. And X goes directly toward the observer. So if you use Cartesian coordinates, it is preferred that you use these so that people who have done solar wind work in the past will know what you're talking about. The punch image plane is XIM and YIM, so that people know it's in the image and not just our standard XYZ coordinates. Epsilon is your curly epsilon. It's called var epsilon in tech. Is your elongation angle. Alpha is your position angle, and they can be read directly off the mosaics. So those angles are preserved by the projection we use. Brightness quantities, do not use B in your paper. B is very confusing, and it could refer to the magnetic field. So use TB for total brightness. PB, if you use PB, which I kind of deprecate but only weakly, it is a synonym for a Stokes parameter. People use PB for total polarized brightness. We do not do that. So total polarized brightness is circ PB, and it has a little circle on the front, and that's what that is regardless of direction. If you were looking at a rotated Stokes-like parameter, you want perp PB or just PB. And when we give you PB in a data product, it's that. Here are some various subscripted brightnesses. These are all radiances. They are not intensities. That is the pixel average value, not a pixel summed value. Intensities of features are integrated over solid angle. They're sums of pixels, and those are intensities. If you take a punch data product calibrated in radians and you sum a bunch of pixels and account for the pixel scale, you will get intensity of a feature. And unfortunately, there's a collision. It's 100 years old between Stokes I and I for intensity, and I don't think we can fix it in this mission, so you just have to be clear which one you mean. And then Q and U are the other things. And we treat all the Stokes parameters as radiances, not as intensity. That's all I got. I just want to throw that up, let you know that these are in the papers and you should use them. Yes.
They're in the paper, this is plural, but it's a singular place that an image go to find all of them together.
The appendix to the punch overview paper is a good place to look, and we should probably put them on the website too.
Yes, that's a great idea. And the punch, the paper he's talking about is almost done.
It's in
just
the archive. I've been
It's
hassling
in
the
the
editor.
archive, but the referee, you just did a response to referee.
I did the response to referee 2 weeks ago, and the editor never sent it to a referee, but decided to check himself that we followed the advice of the referee. So he's told me that we should get an acceptance notice real soon now.
So it should be on there and meanwhile it's on our protection.
In which? Excellent. But you mean perp PV. So you're okay. It fits the guidelines. Yeah, so if you're using it as the square root of q squared plus u squared, that's the little circle PV.
Okay, so. with
Back to you.
everyone calling-